Good morning, good afternoon, everyone. Today, as you know, it's the DLD here. We're making up on Saturday. We finished up chapter 1 at this point, and it's going to kind of be the beginning to our review. Just go over kind of the key concepts in this video, and then let you guys get started on your review guide. So, let's go ahead and take a look. So, the first lesson 1.1, we really talked about expressions and formulas. So this consisted of using the order of operations, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Okay. The multiplication and division steps, those we needed to work to left to right. And the same thing applied with addition and subtraction. They're kind of on the same level like we talked about in class, but we need to work left to right. Okay. So the example you can see here, we're going to be using the order of operations. Other examples you might see in this section would be plugging into a formula. That'd be pretty fair. Or having an expression, an algebraic expression where, you know, a equals 2, b equals 5, and c equals -5, and plugging those values in will also be fair game. But this is a pretty good practice problem, at least. So let's go ahead and take a look at it. The grouping symbols I'm seeing are these brackets, which inside include parentheses. So inside of these parentheses, what order of operations do I see? I see exponents first. So inside of these parentheses, let's simplify the exponents. So 6 squared would give me 36 divided by 3 times 2 to the power of 2. That's an exponent. So that is 4. Continuing simplifying inside of the brackets, which we still haven't simplified. The parentheses, yeah, so I see multiplication and division. I need to work that left to right, so 36 divided by 3 gives me 12. Continue. Now inside the parentheses, I only see 12 times 4, which is 48. Now inside of the brackets, I've got it down to a subtraction and a multiplication. Of course, multiplication comes first in my order of operations. So I need to do 2 times 48, which is 96. So now I'm left with 2 minus, let's simplify the brackets, 20 minus 96. 76. So this becomes 12 plus double negatives, plus 76, which then gets us to 88. So this all simplified to 88. All right. So again, yeah, that was lesson 1. We did expressions and formulas. Again, plugging into formulas or an algebraic expression is also a skill you would need to have for lesson 1.1. This was just one problem I felt pretty complex, quite a few steps, so I thought it was a good example here. Thanks. So bear with me here on this formatting. Okay. I do work with the same every so often, so. All right. Lesson 2, properties of real numbers. We, again, all the numbers we talked about were real. They all fit into the real numbers category. Inside of real numbers, we had a couple of breakdowns. We had numbers that we considered irrational. Which was just represented by I, and we had numbers that were rational, represented by Q. Inside of the irrational numbers, so let's just talk about them briefly. Irrational numbers are non-repeating, okay, non-terminating decimals. So examples of those, pi, 3.1459, continues. Square root of 2, really good example of rational. Square root of 3. Okay, numbers like that would have non-repeating, non-terminating decimals are what we call irrational. Rational numbers are just numbers that you can write as a fraction. Okay, so repeating decimals apply. A rational number, 2 over 3. If you plug that into your calculator, you get 0.666666666. Repeating. That's a repeating decimal, so and it can be written as a fraction. So it is a rational number. Inside of rational numbers, then we had the integers. The best way I described those were just numbers you'd find on a number line, the positives and the negatives. Integer was denoted with the z. Inside of integers, we had whole numbers, which were positive numbers, including 0. That was just a W. And inside of whole, we had natural, which are positives. That's just and positive numbers that don't include 0. So, kind of an idea here. Rational and irrational, I think we have a good idea. Integers, so which are z. The integers, again, just negative. The negatives, -1, 0, 1, all the positives. Whole numbers are 0, 1, 2, so on. And the natural numbers are 1, 2, 3, the numbers you learn how to count. So it is important. These three on the quiz, we had a lot of, I don't know if it was guessing or we weren't confident on what was a natural or a whole number. So make sure we know that, and those definitions are clearly stated in your textbook. But I think maybe writing this stuff out like that would be. All right, and so just classifying numbers. If I were to give you a number, say square root of 4, I'd want you to say what set falls to. So square root of 4 is a real number. Square root of 4 is equal to 2, so that's certainly rational, which is denoted with Q again. Square root of 4 is 2, so that's an integer. It's positive, so that's a whole number, and it's one of those. It's natural. The naturals and whole numbers are the same, other than whole numbers include 0. All right, so that's the type of problem you would expect. Let's continue then. Solving equations. Verbal expressions can be translated into algebraic expressions. The absolute value of a number is the number of units it is from. 0 on a line. So here, absolute value. We solve absolute value equations. So when we think about that, we want to think about, again, having that positive case, the negative case. We talked about this on Tuesday. And so likely you're going to end up with 2 solutions. You've got to check those 2 solutions to see if one is extraneous. Because it is possible that one would be extraneous. So always checking your solutions and setting up both cases. And those absolute values, those are kind of the 2 key takeaways there. And then that last point for any real numbers, A and B, that just talks about absolute value. So example, this is just an example of solving an equation. We'll go through this one, and it's a pretty standard equation to solve. We're going to solve for y. First thing we need to do is simplify that right side. Left side is going to stay the same. It's going to become equal to, we've got to distribute the -3, so it's -6y minus 3. Let's add 6y to both sides. So 12y minus 5 is equal to -3. Add 5. 12y is equal to 2. Divide by 12. Y is equal to 2 over 12. We need to reduce that 1 over 6. Okay. So that's solving equations again. That includes, all the equations from 1, 3, and then our absolute value equation. Next topic is inequalities, and we've talked about inequalities Wednesday, Thursday, and Friday. Solving inequalities is much like solving equations. The same general rules are applying with addition, subtraction. Multiplication and division gets a little dicey because we need to continue to be aware if we are multiplying or dividing by a negative, we've got to flip the sign. Graphing inequalities on a number line. Okay, what's an open circle? What's a closed circle? So open circles are with a strictly less than and strictly greater than. Closed circles would be less than or equal to, greater than or equal to. What direction those arrows are going. Checking to make sure that we've graphed it correctly. Plugging in a value to the inequality. So those are just kind of the main takeaways from solving inequalities. And this is going to be a wrap here on this video. I know we didn't do a ton of examples, but I think just talking through the main key points here and letting you guys actually work out some examples and it's going to be best. So your homework, it's there in the Canvas module. It's Chapter 1 review. Do the evens only. Okay, we'll have time on Monday to come in and ask some questions and make sure we've got a good understanding of this before we would be testing on Tuesday. So, okay, everybody, thanks for watching. Work hard this weekend and have a great weekend.